In this video, we're going to go over both arithmetic and geometric sequences. And then this is part one of a two-part series, which goes through sequences and series. In this video, we'll go over both the recursive rule, the general rule, how to work out both these rules, explaining what the difference in sequences are, and just overall some problems towards the end of the video as well. So the first thing is, what is a sequence? A sequence is simply just a list of numbers. And I'm going to write two different lists of numbers on my screen now. I'm going to write one on the arithmetic side, so 1, 4, 7, 10, 13, and 16. And for the geometric one, I'm going to write 2, 4, 8, 16, 32, and 64. What do you notice between these two lists of numbers? On the arithmetic side and the geometric side, there's clearly a difference because one of them is increasing much quicker than the other one. So what is the difference? Well, let's have a look at the arithmetic sequence of numbers. We can see that the terms before the last, so each term going increasing order, is a change in addition. Okay, for this question, it's a change in addition. To go from 1 to 4, we simply add 3. To go from 4 to 7, again, we add 3. To go from 7 to 10, we add 3, we add 3, we add 3. Okay, so in arithmetic sequences, we have what is known as a common difference between each of the terms. Each of the terms will have a difference with a common amount. In this case, it's a positive 3. Now, what about the geometric side? The geometric sequence here, we can see doesn't really add by 2 each time because we can see this one is add by 2, then it's add by 4, then it's add by 8, but they don't really have a common difference. It's not common between each of the jumps that you see here. But what I do notice is there's a common ratio. The ratio between 4 and 2 is simply times by 2. The ratio between 8 and 4 is times by 2, times by 2, times by 2, again and again and again. Okay, so this sequence of terms on the right-hand side of my screen has what's known as a common ratio. And that is the key foundations of a sequence. You can have a list of numbers that differ by either a common difference, a common ratio, and in some cases even both. But for this video, we'll just stick with just singular common differences and common ratios. Now we have two ways of writing these lists as a mathematical formulae. We can use either the recursive rule or the general rule. And I'd like you to put a little star next to the recursive rule. Okay, and we say this is bad. Okay, in normal questions, this is not very helpful to us to work out large samples of numbers, and I'll explain what that means in a sec. Okay, what I mean by this is let's start with arithmetic sequences, because let's take it slowly, one step at a time. So if we were to do this, what I would recognize is the recursive rule for any arithmetic sequence is written as follows. Tn plus 1 is the same as a plus d, where t1 equals a. And what the hell does any of this mean? I have a t, I have an n, I have an a, I have a d, and I have like one number. When did math become so many letters and no numbers? I'll explain what this means. What this means, by the way, I will replace the a with t1, tn. Okay, what this means is if I want to work out the next term in a sequence, so tn plus 1, well, to work it out, I need the current term, and I would need to add the common difference. Okay, so in this case, let's say I start at 7. If I want to know what the next term is, all I do, so the next term is tn plus 1, I would need the current term, 7, which is tn, okay, 7 is tn, and I would need to add the common difference. And we know that each term is added 3 from the last. So our common difference is simply plus 3. So that's how we get our next term is 10. Okay, but this is kind of vague. How do we know what the previous term is? How do we know what the next term is, right? All we know is plus 3 each time. That's the only thing that's concrete in stone. That's why for a recursive rule, you must also include t1. What is the first term in the sequence? And another way of writing t1 is simply a. A denotes the first term of any sequence. So in this case, a would simply be 1. Okay, so if I would want to work out what is t4, I need the third term in this sequence, plus 3. And I also know that t1 in this sequence up above in dark green is equal to 1. t1 is just 1. So to work out the fourth term, the third term is 7 plus 3 equals to 10. But there is a key limitation. A key limitation with the recursive rule is, let's say I wanted to work out what is T100. I want to work out T100. Well, according to the recursive rule, that would simply be T99 plus 3, where the first term of our sequence is just 1. But the problem with the recursive rule is you can only use the previous term to work out the next term, which is really unfortunate because we don't even have the 99th term. Well, you might say, no problem, let's work out the 98th term, then the 97th term, then the 96th term, then the 95th term, etc., etc., etc. Do you really think that's a feasible thing to be doing and wasting our time? Not really. Okay, that's where the general rule comes in. Okay, the general rule is much nicer to use, and here is how it looks like. The general rule is simply Tn, any term, is the same as a plus the common difference times by n minus 1. Okay, it's a plus the common difference times n minus 1. And I'll tell you what the common difference or the general rule is for the list above. For the list above, we can say that Tn is the same as the first term. Remember, a denotes the first term, which is 1, plus the common difference, which is 3, times by n minus 1. So now if I want T100, okay, our problem is solved. All we have to do is replace n with 100. So we can say 3 times 100 minus 1, which is the same as 1 plus 3 times 99. Okay, and we can easily work this out. 3 times 99 is simply 297 plus 1, which is equal to 298. This is the 100th term of our sequence. How much easier was the general rule compared to the recursive rule? Okay, this is the only limitation you will recognize between the general and the recursive. But it is very useful to understand how does the actual sequence behave using the recursive rule, and that's the only reason we have that rule there. So that's how arithmetic sequences work. Now what about geometric sequences? Again, the only difference between geometric recursive and general rule is the fact that for this recursive rule, if we wanted, let's say, the 100th term, we would need to know all previous successive terms before it, such as 99, 98, 97, etc., etc. You get the idea. So for a recursive rule, for a geometric sequence, the rule goes as follows. Tn plus 1, the next term in a sequence, is simply the same as the current term times by the common ratio, where T1 is equal to A. So what is it for this question here? Well, for this question, we can say that the common ratio is 2. So the next term is simply equal to the current term times by 2, where the first term of your sequence is equal to 2. Okay, but again, you wanted to work out what is the 100th term of the sequence? Yeah, you're going to have to times by 2 100 times, which is not really that interesting. So the general rule, even though it's not, for this particular example I gave you, it's not the best, it still is much better than the recursive. Okay, the recursive is this, the general is the following. Tn is equal to a r to the power of n minus 1, to the power of a minus 1. So if I wanted to work out what is T10, for example, the 10th term, I would need the first term, which is a, so in this case 2, times by the common ratio, which is also 2, to the power of 10 minus 1. So that's the same as 2 times by 2 to the power of 9. Okay, and that is the same as 512 times 2, which is 1028. And that is how you work out the general rule of an expression, of a sequence. These are the only two differences between arithmetic and geometric sequences. So let's have a look at a few questions now. Okay, so the following here is the first 3 terms of a sequence. I've not told you whether it's arithmetic or geometric, but let's work out the following questions. Question 1, is the sequence, is it arithmetic? Is it arithmetic or is it geometric? Well, in this case, we can recognize, is there a common ratio or a common difference? That's the only thing this question is asking us. So let's see what happens. To go from the first term to the second term, we are minusing away 4. And to go from the second term to the third term, we are also minusing away 4. So that means we have a difference between these three terms, but it's also a common difference. Okay, so because it's a common difference, we can say it's an arithmetic sequence. Step 2. Work out the recursive rule for the following list. Recursive rule. Well, the recursive rule for this expression here is simply in the form Tn plus 1 is the same as Tn plus the common difference, where the first term is always equal to a. And you must always include this. If you forget to include this, the entire rule doesn't really work because you need the first term to kickstart this entire sequence. So for the following here, all we can say is the next term, Tn plus 1, is the same as the current term plus the common difference. And the common difference in this case is minus 4. So all I can write is minus 4. And in this case, the first term of our sequence is 3. And the third question, what is the recursive rule? Sorry, what is the general rule? The general rule for this question is in the form of Tn is the same as a plus d times n minus 1. For this question, the first term we recognize was d, was 3, and the common difference was minus 4. So minus 4 times n minus 1. Okay, now the next step is to work out the 54th term. Okay, what is the 54th term of the sequence? Okay, are we going to use the recursive rule in this case, or are we going to use the general rule? If you said recursive rule, please rewind to why I said we don't. But if you said general rule, good job. Let's continue on with the general rule. So T54 is the same as 3 minus away 4 times by n is just 54 minus 1, which is the same as 3 minus 4 times 53. So now we can say that 50 times 4 is 200, minus away 12 is 212. So 3 minus 212, which is the same as minus 209. And that is the 54th term of this sequence. The next question is this. This is the first three terms of our sequence. And don't get it confused. It's 5 minus root 5, 5, and 5 plus root 5. Those are our three terms. So we're going to do the exact same questions again. 1. Is it arithmetic or geometric? If you said geometric, you would be incorrect. It is actually arithmetic. Okay, and the reason so is because to go from 5 minus root 5 to 5, that's the same as just adding a square root 5. And then to go from 5 to 5 plus root 5, that is just the same as adding root 5. So our common difference here is root 5. Second, what is our recursive rule? The recursive rule for this question is in the form Tn plus 1 equals Tn plus d, okay, where the first term is equal to a. So when doing this, we know all our common differences as well as our first term. So let's just write it. It's just Tn plus 1 is equal to Tn plus square root 5, where T1 is simply equal to 5 minus root 5. Now let's continue. 3. What is our general rule? Okay, the general rule is much more practical in certain cases, and the general rule is in the form of Tn equals to a plus d times n minus 1. So in this case, we know that T1, the first term, is simply equal to 5 minus root 5, okay, plus root 5 times n minus 1. Okay, and if you want to even simplify this even further, we can say this is the same as 5 plus square root 5 times n minus 1 minus 1. And the reason I've done this is because I factorized out root 5 from these two terms here. And that just simplifies to 5 plus square root 5 times n plus 2. So n take 2. And step 4, I would like you to work out the 49th term of this sequence. Okay, what is the 49th term? So Tn, in this case T49, is the same as 5 plus root 5 times by n minus 2. Okay, in this case n is just 49 minus 2. So now we're going to say 5 plus 47 times the square root of 5. This here is our 49th term. I'm not going to work this out exactly, but there you go. That is how you work out the arithmetic sequence information. Okay, the next three terms we have is 1, -1/4, and 1/16. Okay, So the first question is this sequence arithmetic or geometric? Well, if we look at this question here, okay, to go from 1 to -1/4, we timed by -1/4. To go from -1/4 to 1/16, we also times by -1/4. So we have something common. In this case, it's not a difference, it's actually a ratio. Okay, we have a common ratio. So therefore, for question 1, is it arithmetic or geometric? We've just worked out it's geometric. Second question, what is the recursive rule? The recursive rule is in the form Tn plus 1 is equal to Tn times by the common ratio, where the first term is simply equal to A. Okay, the first term is equal to A. So continuing on, Tn plus 1, if we were to work it out for this question here, Tn plus 1 is equal to the current term times by -1/4, where the first term is just equal to 1. Okay, continuing on, what is the general rule for this geometric sequence? The general rule for this arithmetic sequence is in the form of Tn plus 1, or no, not Tn, it's just Tn is equal to AR to the power of n minus 1. So in this case, we know that the first term is simply equal to 1 times by -1/4 to the power of n minus 1. And we can just write that as -1/4 to the power of n minus 1. So now I would like you to work out, for question 4, what is the 8th term of this sequence? Okay, what is the 8th term? Well, I would use the general rule in this case. So the general rule states that T8 is the same as -1/4 to the power of 8 minus 1, which is just -1/4 to the power of 7. Okay, to simplify this, that's the same as just -1 divided by 4 to the power of 7. Okay, -1 to the power of 7 times 4 to the power of 7, -1 to the power of 7 is just -1, divided by 4 to the power of 7. I'm not going to work this out, you can do this at home yourself, but that is how you work out the 8th term of this question. And that's how arithmetic and geometric sequences really work. We will go through more problems in a later video, but for now, this is how sequences work as a basic.